Hey, it's John, RMUS, VP of Technology. Really great show today. The start of and kickoff of our Tech Week is bringing in DJI to talk about the P1 and the L1. So we'll be discussing this and kind of showing this show, talking about this unit right here. So unfortunately, I've only got a P1 in my hands. I did have some time to mess around with the L1 back in December. Thank you for DJI to allow me to actually do that. But as far as the M300, the combo of this, I'll move my coffee cup out of the way here. This combination right here is fantastic, the P1, and we're going to learn a little bit more today. But I wanted to talk to basically the crowd and make sure that if you guys have just a little housekeeping things, if you guys have the chat on the side, the chat is good for basically talking to each other or even adding to the conversation if you want to in the chat. But about 3/4 of the way through, we'll open up a section for Q&A so that you can ask myself and the guest here today, Ron Lee from DJI, some questions about the presentation or any more in-depth. So try to keep it pretty clean. This is going to be there's a lot of people watching this particular webinar today, so we'll try to keep the questions pretty clean, pretty precise, and we'll try to keep the answers just as so. So anyway, without further ado, want to introduce the amazing Ron Lee. Definitely this guy is one of the top engineers there, my super helper when it comes down to asking questions. So when we just come down to running into issues and problems and hiccups on our side, it helps the customers like you out there to get this information to people like Ron immediately. He can then get that information back to us so that we can help troubleshoot or figure out those things. So let me go ahead and introduce Ron Lee here.
Hi, John. Thank you for the introduction. I really appreciate that. For everyone who don't really know about me, my name is Ron, and I am a solutions engineer working in DJI Enterprise. My primary role is to work closely with our channel partners, which being RMUS being one of the major ones, as well as our solution partners to come up with various solutions for the drone market or industry overall. I'm super excited today to introduce P1 and L1 surveying systems today with, of course, RMUS and John today. Pretty excited. Excuse me, I think I don't have audio from my side.
Did we lose audio? Oh, of course. Jay's the audio guy. I'm gonna hit him in the head again one more time today, so it's okay. I was gonna just ask you how long have you been there at DJI? As far as and then you're located here in the United States.
That is correct. I'm located in Burbank, California, and I've been working for DJI Enterprise for a little over 3 years. Yeah, a little over 3 years now. So yeah, and my primary role can be seen as two parts. One part being collecting user feedbacks, basically from the industry. It's how people using our drones, just in short. The other side is internally report these feedbacks and how we can improve our products, especially on the enterprise market better to fulfill everyone's needs.
Well,
it's really like my work.
Like I said, I really do value having people like yourself available to answer those questions, especially when it comes down to getting the more emergency issues to you. By then you're sending it up the chain or wherever it needs to go. So it's very valuable to me to have that relationship, So thank you again. I can't thank you enough for being here and helping us today. So yeah, with that, like I said, I don't want to delay the presentation or what you wanted to talk about today, but I know we're going to hit hard on the L1 and the P1, and then a little bit of discussion about Terra. Then we'll open it up for Q&A. So without further ado, like I said, I'll go ahead and let you take it on.
Sounds great. Sounds great. Let's get started. I'm gonna share my screen now. Okay. Okay, then to begin our webinar today. So today's webinar, I'm gonna briefly cover these two new products, L1 and P1. As you can see on the screen, I have two products over there. But for today's content, I'm gonna briefly go through DJI surveying solutions overall, which includes these two amazing products. Moving forward, introduce the L1 unit and some case study and applications of L1. Moving forward, I will be talking about P1 applications and case study similarly. Okay, let's get started. I'm gonna talk about the surveying solutions. So we have rolled out many products for the past few years. And some of these products are focusing on surveying applications and surveying solutions. For example, we first announced the DJI Phantom 4 RTK being the first all-in-one RTK system DJI ever announced. And after that, we have launched DJI P1 multispectral, which is similar to the P1 all-in-one solutions, but the payload, we have changed that to a multispectral camera system. Afterwards, we have software released, which is being the DJI Terra for photogrammetry process, LiDAR data process, many other features packed into it as well. And recently, last year to be exact, we have launched the DJI P1 and the DJI L1. So those two payloads specifically designed for M200 platform to work seamlessly with DJI Terra and other software we have released recently as well, providing advanced visible light applications and visible light surveying applications and LiDAR surveying applications. So I'm going to first briefly cover about the DJI M300 first. It is overall the platform is going to carry P1 and the L1. And it's going to be the platform for other payloads we have as well. So we launched this product as a versatile platform. Basically, want users to attach any payloads they want for different applications. It's capable of doing over 50 minutes of maximum flight time, which is great. 15 kilometers of maximum transmissions, full HD. It is just reliable and it is just strong, and it is IP rated as well. 6 directional sensing positioning, and most importantly, supports RTK and PPK for precise surveying application work. Okay, and I'm gonna start talking about L1 from now. And again, these two products are can all be attached to that drone, as I mentioned, M200 RTK drone, as a part of the solutions. So there we go. This is what it's gonna be like with the drone attached to that L1 sensor. When people look into L1 sensor, I got multiple questions. Actually, when we first launched the product, about the LiDAR unit. And it's actually not only a LiDAR unit, it is actually a fusion unit with a RGB camera as well. If you notice, on the bottom of the LiDAR scanner, there's a RGB camera. And that same camera, has the same spec as a Phantom 4 RTK. So it is a mechanical shutter camera designed for surveying photogrammetry captures, and it is 20 megapixel. So that makes the L1 not only a LiDAR scanner, aerial LiDAR scanner, but it's also a aerial camera for capturing visible photogrammetry data. So, which is pretty handy when you think about it. It attached to the M300 again, yes, and the LiDAR itself is a unit we have from a company called Livox, which is a professional LiDAR sensor manufacturer company. Okay, and it supports multiple returns up to 3 for the LiDAR unit itself, and it supports real-time point cloud live view with the mobile application. So first responders, emergency applications, user can use the L1 to generate point cloud within real time, and that point cloud is in color because of that RGB camera on the bottom of the LiDAR scanner actually capture the RGB's data as well. This is extremely brief. I'm just trying to go through the product extremely brief, and we're just gonna jump into the applications already. Some applications we have, obviously this is a product for great tool or a great product for topographic surveys. So for users seeking for digital elevation models, digital surface model, because of the penetration rate of a LiDAR and its characteristics, people can use LiDAR to generate digital surface model easier. And that is great for using aerial LiDAR to cover a great amount of area. We have many applications as well. We have a good amount of public safety entities currently utilizing our M300 drones, and other entities utilizing M300 drones. For example, energy, gas, power. They just have the M300s, and they use other payloads as well. So this is going to be a great additional payload they have for inspection and for mapping. So many applications such as forestry as well for resource management, and with data of LiDAR captured from L1 sensor, a user can categorize species of the vegetation utilizing the L1 data. And because of its aerial, you get to cover a lot of area as well, which is great. And another thing is emergency mapping, which I sort of like briefly covered already. L1 is designed for emergency mapping as well, because of that real-time mapping, real-time point cloud generated directly on the screen from your remote controller. You get to see detailed items on the screen. You get to do a simple measurement on the screen as well, just to get the first-hand information quicker. This is one good example, and how people are currently utilizing L1 or generally LiDAR data, right? So you first capture LiDAR data, and that's a point cloud data you captured directly using L1, flying over the interest mapping site, and you gather this LiDAR data. And from that data, you actually generate multiple layers of useful information. For example, if you are to do classification work, you actually can filter out vegetations out from manned structures. You actually get to filter out, and you can categorize these species, for example, utilizing software algorithm. And you can also filter out the structures, all of the structures, including vegetations, to generate a clean model of the ground, of the surface. That's where the digital surface comes pretty handy, and utilizing LiDAR data, because you no longer have obstacles or objects above the ground to block that level of the model. So from there, once you have the digital elevation model, for example, you get to generate more useful data, which is being the counterline. There are softwares out there. Terra outputs a digital elevation model as well. There are multiple third-party softwares out there can do that automatically, and that process is getting a lot easier these days, especially with these new softwares out there on the market. It is another use case, for example, it will be inspection work, and using LiDAR for inspection work is extremely easy because you no longer need to process out the data just like a photogrammetry. You actually output this data already, and these point clouds are captured directly, as I mentioned, from the sensor. So all you need to do is output and convert to the format you want. That's it. No more processing work needed. So this is extremely easy for inspection work, such as over a bridge. For example, this one is a Yangtze River bridge, which the focused length of this bridge for inspection is about 6 kilometers. And utilizing DJI software, flight controller software, people actually get to create an inspection mission pretty easy and very straightforward, directly on the RC, no computer involved. User need to plan out the missions, select the interest area, and hit go, and the drone will take off, and L1 will start capturing data. So it's extremely simple and intuitive. Similarly, another application utilizing our software integrated into our RC is, of course, a power line inspection, and LiDAR, utilizing LiDAR for power line inspection is another great example for showing the advantage for utilizing LiDAR versus a photogrammetry sensors, because the wire is extremely thin. Sometimes if you don't have enough overlaps, you will miss all the lines, power lines in the middle. Utilizing LiDAR, that's no longer a problem. You just need to have a surface for reflections. That's how LiDAR works. And with LiDAR, it's extremely easy to capture all that detail. So you get to see the hand, the lowest point of the power line, all that, and extremely easy to gather all these data. Similar to the bridge inspection workflow, user will only need to create a mission and plan out the mission on their applications directly from their RC, and export to the flight controller app and hit go, and the drone will just take off. For example, this one, the L1 plus the M300, which is being the drone, can complete this mission within just 5 minutes, and it captures all the data needed, and everything. So extremely straightforward. So that's just extremely brief through of the L1, what it's capable of, and some applications, as I mentioned. Before I move to the P1, I know you guys may have many questions already. If you have any questions, please feel free to ask in the chat box. And I'm gonna pause for a second. And John, do you have any questions so far?
Oh,
now you're like, there you go.
there we go. We did it again.
Jace,
I'm gonna poke him in the eye the next time he does that.
I'm doing several jobs here, okay?
Got it. No, Ron, I think we're trying to hit all the questions as fast as we can inside the chat window, even though I will open it up to a Q&A. But probably the most common one I've seen here, or one that I've been asked most often, is how does Terra kind of fall into this? You know, how does the required software? I know from my experience running that, we're bringing the data collection, the real-time data collection, I also wanted to note that for the recommended flight height, 50 meters, flight speed, 10 meters per second, that's the optimal flight height and flight speed for this sensor as far as data collection goes. So just keep that in mind for you users that are like, I want to fly it at 450 feet. Not optimal for that. So 50 meter height, 10 meter per second, or 10 meters a second. And the question I had was just with Terra, I was able to collect the data, put it into Terra. There's a processing piece now to Terra, in which then kicks you out an LAS file that is saved into the file structure of the DJI software. So I guess my question is, even though I answered it, we have to use Terra in order to do this portion of the process.
Yes, and so the software portion, which is being Terra, is free, and it comes with the L1 package. So what Terra does is exactly what I mentioned. It converts the raw LiDAR data captured into usable deliverables, and such as LAS format and a point cloud used for website even directly.
Okay, and then this dually, because you brought up the RGB camera, you will also need Terra to do colorization as well. So if you want to colorize the point cloud, taking the RGB data that is captured at 20 megapixel plus the LAS file, well, it's basically generating a colorized LAS file, but you'll need both of those to then do the processing within Terra to then output a colorized LAS.
Yes, exactly. If colorized point cloud is needed, user will need to import the photos as well captured from the data.
So what's the other little sensor on there? What's the other little camera on there? Since so many people ask me that as well. There's another little front on the front. I'll let you explain. So we have we have the LiDAR sensor, we have the RGB, but then there's this other little thing, and people are asking, is that the wide view? Is that a scanner? Is that a laser? There's a lot of questions there.
That is actually a great question. I don't really get that actually. That is actually a grayscale camera. It is for backup use, because we know LiDAR, especially aerial LiDAR units, they depend heavily on the IMU units built in, and that's why currently we're still doing in the test phase of the L1. Our system will require RTK connections for L1 to generate reliable data. And that small sensor over there, right next to the RGB camera, is to ensure the quality of the IMU. Because if the drone lost the connection, for example, or lost the RTK connections, for example, it still be able to maintain good quality for a short amount of time, like 30 seconds, without warning users, okay, your data is getting not reliable and it's not usable.
Yeah.
So that's what that little sensor is for.
Perfect. No, let's continue on. I know you have a lot more to talk about for the viewers that are watching. I'm watching questions just coming through the chat like crazy, so I'll try to answer these the best I can while Run is talking about the P1 here. So we'll try to do a couple of like I said, I'll try to hit the questions, answer them the best I can. If I can't answer them, we'll open that up to Run Lee if it's a little more complex. So go ahead and share your screen again, Run, and we're ready for you to kind of talk about the P1.
Great. Let's resume. Let me share my screen again. Okay, with that being said, let's talk about P1 afterwards. So similarly, I'm gonna give a page or two just to briefly cover what P1 is, what P1 is capable of, why do we have P1, what's the point of having P1. So P1 is a sensor, again, for surveying use, but this one is actually a more traditional RGB camera. And it is actually the first full frame sensor, visible light sensors DJI ever announced, and targeting for the surveying market. So the sensor built into the P1, which is biggest selling point, of course, is the full frame, capable of doing 45 megapixel ultra high resolution image, and it is extremely efficient. The lens of the camera is interchangeable. We do provide many options to the users. Depends on how high they want to fly away from the interest surface. So yeah, we have multiple options as well, multiple options for the cameras, and all of the lens we provided are mechanical shutter. Mechanical shutters can, if you are familiar with aerial photography, you probably know that mechanical shutter built into a camera is extremely helpful for reduced rolling shutter effect, and that is crucial in aerial mapping, because that means you can have your drone fly faster, or other way, you can have more reliable data sets. You don't have to worry afterwards. It's equipped with TimeSync 2.0. That's microsecond level system synchronization. Basically, what it does is it synchronized the GPS position, the offset between the RTK antenna to the center of the pupil. That information, because the camera is constantly moving, that's why we need to have that synchronization, especially for large drone like MT-100. That is extremely important to improve the vertical accuracy. So that's all synced up in microseconds because of the TimeSync 2.0 technology we have. And most importantly is that smart oblique capture feature we have. This is something I specifically want to talk about. It's extremely interesting. Basically, what it does is it will capture oblique image sets utilizing L1. But good part of this is it will only capture useful data sets. So conventional cameras with the oblique imaging mode we have on the software, they tend to capture photos from all kinds of directions, right? Even though some of the data are kind of useless because you're capturing photos oblique to the outside of the mapping area, which is useless. So we have this feature now. It's called Smart Oblique Features. It will only capture oblique image direct toward the interest center of the map. So what it does is it reduces significantly amount of the data needs to be captured. So that reduces the data needs to be processed as well. When you think about it, less image, less time to process, of course. And another thing is it improves the overall performance by boost up that speed. For example, if I need to take 5 photos, the drone would automatically slow down to take 5 photos. If it only need to take 3 photos, for instance, it will speed up. As you can see, I have this little video just to demonstrate how exactly that's going to be like. But with this feature, it improves the overall performance of the L1 in terms of capturing oblique data sets a lot. I will be giving some example afterwards, just to kind of go over this. But again, what P1 is it is a full frame sensor capable of capturing 45 megapixel stills, aerial stills, and the sensor has a great high dynamic range for all-time use as well. One of the biggest application will be cadastral survey utilizing aerial drone. So previously, when you were thinking about capturing a data set that large, you probably will turn over to satellite imagery or manned helicopters. But those cost extremely high, costs extremely high, and the data you don't have the data. You cannot have the data update constantly. But with a drone, you can simply have the drone fly over the mapping site or interest site once a week, twice a week even, if needed, because the data or because of the time and resource spent on the drone to capture all these data is extremely simple and easy and efficient. For example, this is one example utilizing P1 camera, an M300 platform drone, to capture a site. This site is over 2,400 acres, and for this example, we can finish the site, capture all the photos we need within 9 flights. That's within a day. Image total captured is about 6,000 photos. Ground sampling distance being 3 centimeter per pixels, and flight height for this is 240 meters above takeoff point. And it takes the computer only 9 hours to process. And this is not like crazy supercomputer either. This is regular computers with a graphics card of RTX 2080. So the result is stunning, and as you can see, the image doesn't have much of dimming. I don't know, when we go to the Google Earth, for example, we see one section of the map is slightly dimmer than the others. That is because data were captured from different time of the day. As you can see from this one, it looks great, and the light is good because of the high dynamic range of the camera. So that's another thing good about the P1, is because of the high dynamic range of the camera, you can actually operate more time because of the lighting condition is not as will not affect as much as other cameras compared to P1. This is just continuously studying this 2,470 acres project. We placed 47 checkpoints, and we scatter these checkpoints all over the map, as you can see on the graph on the left. And none of these checkpoints were used for ground controlling points. Okay, so we didn't use these points for ground controlling points. In case you guys don't know, ground control points would help improve the overall accuracy of the map generated, because it will warp the overall model by utilizing these points. But for example, for this case, we just use 47 points for verifying the accuracy generated from the P1 data, excuse me. And the result is within 6 centimeters, within 6 centimeters in both vertical and horizontal of the data. So this is extremely good. That means the P1 would require no GCPs and still be able to achieve 1/500th surveying grade level of data output. That is significantly accurate, just like P4 RTK. This is another example. This is the one actually utilizing the smart oblique feature I just talked about. Pretty interesting, and we actually did a comparison between the P1 and another payload, which is being the professional 5-direction oblique camera payload. Those payloads will be used specifically for capturing oblique data sets, right? So basically, it's a payload with 5 cameras, one pointing directly to the ground, 4 pointing to at each other, each directions. So based on our experience, for this specific applications, or for this specific example, the P1 capture only 1/3 of the photos, and still be able to generate great results compared to the oblique 5-direction oblique camera sets. Total amount of time to capture is only 28 minutes. It's only 28 minutes. Extremely efficient again. Extremely efficient for the team, both the team on the ground to capture all these photos, and extremely efficient for the team at the office to process these photos. And we also have a smart reporting system built into the remote controller. So in case you accidentally knocked one of your or touched one of your base stations and causing the RTK to drop connections, the operator on site would be able to see that and be able to refly the mission without get back to the office and realize, oh, all the photos are not RTK fixed, which are not usable. So these small features are all included as part of the solutions and extremely efficient after all. So that will be all for the P1. I know, John, you have the P1 unit with you for a while. I don't know if you have any other questions, but I would leave the stage to you and share my screen for now.
Excellent. Hey, great presentation on this run. I think, like I said, obviously we have a ton of questions that are populating here, that are popping through on the chat. I apologize for putting the question window in the middle of your presentation, but I was just checking to see how that button actually functions. So my bad. That's me not knowing my tools that I have available to me. And yeah, Jace is doing a much better job to make sure I'm unmuted when I'm supposed to be unmuted.
You get
Thank
a
you,
pass
Jace.
and I get a pass.
Thank you, Jace. Anyway, great. Like I said, great presentation. Very on the technical side of things. I think what what I'm getting a lot of the questions here is, what the processes are going to look like, how good the IMU is, can we get trajectory, things. So these might be a little bit more information to where, myself and Run and anyone else that might be able to give some input here on making an actual more, very deep dive. I know, Run, you and I had talked about this earlier, is that probably the expectation is people want to know specifically how to do things with this sensor and the very high technical side of stuff. But, it's kind of hard to cover that in a short amount of time. So I will try, let's just make let's do a discussion on the Terra and how that kind of works, overall, again, with the P1. So we already talked about it and touched it with the L1. You have to have it to do processing, to create and generate an LAS file. From here, you can go ahead and take that LAS file, whether it's colorized or not. You can move that into a software like Cloud Compare or Rock Cloud, any of these types of softwares in which you can analyze it, look at it, classify it, change it. But I did have one question here about adding ground control within Terra. Do you do that? Do you add ground control in Terra, or is that a process in which you do it after the fact in one of these other two softwares I just mentioned?
Right. That is actually a good question. We're currently working with the L1 datasets at a ground control point. That's currently in progress. I don't want to make any promises on that feature specifically on Terra side for L1, but for photogrammetry process, any photogrammetry, that means data not only captured from DJI drones, not only from P1, but all aerial photos can be, a user can add ground control points directly into Terra using Terra. Yes, that is currently doable. Yes.
Yeah. So any photogrammetry imagery, but you're still kind of working it on the L1 side of things to add ground control. Is that okay? Very good.
That is right.
Okay.
That's right.
Very good. And I do know, even though that process might not be available or it's taken a little time for DJI to get this, to get that under the L1, I also know that you can do this in any of the other softwares. So you can add ground control, figure out exactly where your points are going to lay and what projection you're going to put it in. So I do know that you can do that after the fact, which we've already done with L1 data sets. So just, work on that one, Run. as far as capabilities. I think probably the next question here. You mentioned that the Terra is coming with the purchase of these, or free. So I know you can download a free version of Terra. And I know also that you sometimes need a license to do certain things. So just to clarify, if people buy it, they can always download the free version of it straight from the website. But you may need a license to do certain jobs within Terra or opening certain licenses. Is that correct? Just confirming that.
That is correct, John. And the license will come with the purchase of a P1 or L1. It's going to be a pro version, not going to be a free version, which enables users to process 3D model, master model, point cloud, or 2D map.
Excellent.
Free version won't allow you to do that.
Okay. Let me see. Try to get back to the questions here. Is the P1 restricted to a JPEG format? Can it be done in RAW? Is there an output for that? Is it JPEG only, or is there a different type that you can actually save the file format in? That's a pretty good question.
P1 would output RAW format as well. The RAW format we have is DNG.
Okay, for DNG, on DNG. Yeah.
Yes.
Thanks. Okay, Adrian asks, which is a really good question, even though I already covered this one a little bit. Why is the recommended flight speed for the L1 10 meters per second? Will you get data gaps if you fly faster? Yes, that's just a quick answer. You will get, the faster the drone flies, with the way the LiVOX sensor hits, you're getting 2 to 3 returns on that. You want to cover as much as you can. So being that it is the LiVOX sensor and not one of the Velodyne pucks that collect a lot more points per second, you definitely want to limit how fast the drone flies to get that coverage really well as the height is very important as well. So just keep both of those in mind, that if you push those, you might not get the data that you actually thought you were going to get. So make sure you pay attention to the recommendations from DJI on the flight height as well as the flight speed, and that is the main purpose. You will end up not getting as much as you want. Let me see here. Trying to get to a couple more here. What is the noise of the L1 when taking a profile over a flat surface? So I guess we're talking about, again, it's another great question from Adrian. What we're talking about here is when you look at a flat surface and the laser is hitting it, how fuzzy is it? People call it fuzzy. On some LiDAR, you have a very specific, you can see across the data set that it's very flat, but, how fuzzy, I'm sure there's not a scientific how much it is. I mean, there might be, but Ron, do you have any experience with kind of looking at structures that have kind of flat surface, if the points are kind of fuzzy or are they not? Kind of what is that experience on that, if you could share that?
It is not fuzzy from my experience, but just like what you said, that really depends on the surface. It includes the reflectivity of the surface. Mm-hmm. Like many factors will change that as well. But currently, based on my experience in testing the L1 unit, beta unit we have, I haven't had a fuzzy point on flat surface.
Mm-hmm. Okay, so I guess and like I said, I've been asked a million times for data sets from the L1, which we'll be able to provide here pretty soon, as soon as I get a more production kind of model into my hands to be able to fly and test and kind of get that out there for you guys. So the data sets are super helpful in some cases, but in other times, we got to be very cautious on data sets, because once they're out there and people are like, well, this isn't exactly what I thought it was going to be, there's a lot of adjustments and a lot of things that you can manage to change without making so I'm hoping to get the best data sets out there for you guys. Let's see. From Carrie, I'm going to guess that Carrie Does DJI Pilot or Terra allow you to communicate with FAA directly when operating the system near the airport zone, or what can software can help with this? So I'll just answer that one. DJI Pilot has ADS-B in to allow you to know where aircraft are, but there's not a direct communication to FAA like Lance or anything like that within Pilot or Terra. So considering that the product itself is a global product, which would talk to many different civil aviation type people, FAA, CAA, whatever it is, wherever they are, it's probably a little bit more complex. Although you can, in the United States, go to the drone zone, jump in there to get requests on Lance, make sure you have your 107 stuff, as far as the right credentials to go ahead and request those Lance areas. So that is a good question, just to understand where Pilot isn't limited, but more than capable to do all the flight stuff. Tim S., at the beginning it is said the P1 could do PPK as well as RTK. How does that work for the PPK? So, just a question on PPK portion. What do you have an explanation of a little bit of the workflow on the PPK?
Certainly. So how PPK works with P1 currently is the P1 would actually generate PPK needed files that includes the satellite observation data, the timestamp of all the images, and they will put all the photos into the photo set folder for photogrammetry process. And before the photogrammetry process, user will need to generate a fix for all the individual photos, including their individual positions. And after they finish that, they rewrite the position of the image of the photo, rewrite all the image positions. They get to reload them into photogrammetry to process. So if you guys are familiar with the P4 RTK, that process is exactly the same. The data format is exactly the same as well.
Excellent. At least try to keep it clean like that. People that have familiarization. Now I'll ask my own personal question here, Ron, because we have a lot of people that would have to invest into an M300, multiple batteries, maybe a ground station, new P1. This is a much more expensive setup than using a Phantom. What do we take advantage of? You had said 45 megapixel and a 28 minute flight that captured such a huge amount of space with great detail. I think that's the advantage here, but do you think the cost, kind of falls into this for a lot of people? Do you think that's too expensive for them? The workflows are very similar. What is your perspective there of just why you would end up going with a P1 over a Phantom 4 RTK?
Right. So those products are all designed for visible photogrammetry process or that workflow. And it's good to compare these two, and we see it as intro level and high level. And because we separate these two products or solutions based on their performance. We did specific tests on these two products just to compare their performance, and the result is over 10 times. That is the major difference. And when you're a customer constantly focusing on large mapping site, which needs the data output quicker and easier and faster and more efficient platform. And M300 is also, as you said, you have many customers on the M300 already, versatile platforms. So you get to change the lens, unlike the Phantom 4 RTK, you not get to change it. It's more like all-in-one solutions. But we really differentiate these two products based on their performance, and based on the application that really matters.
So perfect, and again, that changing the lenses definitely important when it comes down to certain workflows. So I agree with that. With a fixed lens versus being able to kind of dial in what you want, helps you with the heights if you have some restrictions on that. So that's awesome. Gage here asked a really good question, and this is a general question. With no GCPs, are you still trying tying into the DJI base station and using RTK? And I'll answer this one real quick. If you're not using GCPs and only using the DJI RTK ground station, you will want to be connected to another node, N-trip, or put the known point somewhere. This is good for gathering data on a small scale, 50 acres, maybe 100 acres. But if you go any bigger than that, you will definitely want GCPs out there, regardless of how you use the RTK. This just helps, clarify where those points are going to be. It doesn't stretch the map. It doesn't do anything like that. So that's just my recommendation here. It's highly recommended from me to use GCPs all the time, regardless of whether you're doing RTK or not. And what's really nice about the RTK, at least in the DJI systems, is that they're really good at holding their altitude and holding their direction and really being precise flying. They're also doing RTK as well, but that precise flying is super helpful also, which is not built into a lot of the RTK systems that are currently flying today. So just throwing that out there. Hopefully that helps in telling people you got to use GCPs. James McDonald asked a pretty good question. Will the P1 be given the option to orbit a waypoint in later updates for the pilot app? I know that, like I said, kind of pushing this stuff to you, Ron, seeing how important like some features might be later on. Is this how difficult can this be, to add waypointing or adding basically a point of interest, kind of an orbit kind of thing, is it not intended to do that? And I also wanted to clarify, is it good for inspection at all, single point imagery? So 2 questions. How easy is it to make it available to do new functions and features? And will the P1 be good for any single point inspection?
Well, I'm going to answer the second one first. The P1 is definitely good for single point inspection use. And that, again, is because of the high rest. For existing customers, we're already having some clients utilizing P1s for inspection work already from energy site. And for the feature-wise, that is a good question. Point of interest, orbiting around the interest of point is currently not available. However, we are indeed adding a lot more features specifically for surveying into DJI Pilot app. And that is actually coming within this year. We actually would have a lot of features coming out this year. For the Ground Station Pro, we might add support as well. So if we do add support for the P1 unit, that feature will be available because Ground Station Pro supports that. That is our iPad app, just in case you guys don't know.
Okay, and I always get last question. Thank you for that one, by the way. Last question, and I won't say it's the very last one, but we've got about 5 minutes left of the presentation. I'll try to hit a couple of more, but can you put... you can see I have a single mount here. Can I put multiple mounts when it comes down to this? And why is the purpose? Why is the reason I can't run a P1 and an L1 together?
Right, I do get that questions a lot. Answer first is because of the processing power of the M300. The one of the reasons why a P1 and L1 don't support previous platforms, which being the M200s, is because of the processing power. M300 packed with a little computer, basically. That's why it's capable of doing AI tracking, predictions, and all kinds of computer vision work. But main reason is because of the bandwidth and processing power. Users cannot attach 2 payloads at a time to the M300. Yeah.
Well, at least as far as the L1 and the P1 together, does this also maybe have a little bit to do with the, because I know on the X7 it was really important to understand where exactly you were going to put that in a position on the drone, the physical position. So if we had a dual mount, it would move it over here. It could kind of mess with that. data as far as where do you think that maybe might have a reason for that as well?
That has to do with it as well. As I mentioned, we record the position from the Arctic antenna to the center pupil. And once you replace the P1 or put it on a different position, we need to do software work as well to just generally have that compensated data recorded. Mm-hmm. And that's not always the same.
Definitely makes sense. That definitely makes sense to me. So let's see. If you can go in, taking a look at a couple more here. David Harries asks, what is the real-world laser range of the L1? So how far does it go? Because in reading, understanding that like we do have a range limit, and that's very important to understand. Even the high-end LiDARs can only go so far. So what is our range limit on the L1?
Based on my understanding, it is 190 meters for the L1, furthest range.
Yeah, perfect.
And that actually has to do with the reflectivity as well, a little bit actually, and the lighting as well. But it's 190 to be safe.
Yeah.
To that word, just do that range. Yeah, 190 meters.
Okay, hopefully I've got most of the questions here, but I'm going to ask, this will be our final question, and then we'll have a discussion about something that's come up here. So we basically want to make sure that the L1 does have terrain follow, and the P1. So we can terrain follow with the L1 and the P1. But I did watch, and I have another training video coming here soon, on how to ingest a DEM model into Terra, then using that model as the terrain following. That's kind of the procedure. So we'll bring in a DEM that's already been created into Terra, or create that in Terra or Pilot, and then once it's in Pilot, that's the working model. Like that's what we work from, and then we can tell Pilot app to go ahead and follow the terrain. Is that kind of the workflow I'm thinking here, Ron?
That is right. So in order to do terrain follow for both P1 and L1, user will need to have a digital elevation model, which Terra is actually capable of generating these models. Right. From that generated digital elevation model, the user will need to generate a world file, which is a TFW format. This is a pretty easy format because the file is generated based on the model. Afterwards, you just put those files into the DJI Terra, and our software automatically recognize these files and generate almost like a heat map, but elevation map. So you actually see the height of all the waypoints from the mission generated.
Excellent. Yes, excellent. So that is a feature that you'd need to put into, once it's created, put into Pilot, tell Pilot it's going to go ahead and fly it in a manner to follow that DEM. All right, very good. Okay, last question before we wrap it up here, and I don't know if you have any information to this. Is basically availability run. So it's definitely a lot of people are excited to get this in their hands. I know, being an enterprise dealer myself, the P1 has been kind of a challenge to get out there. I know it's taken a little bit more time in the production side of things and the manufacturing side of things. L1, we've been talking about it for almost 6 months coming up now. So, and again, it's okay if you don't know the exact answer to this one, but what is it looking like as far as availability and getting this out to the masses so people can start using them and collecting data?
P1 is already available today. So I don't know if that's true. Yeah, that is true. Okay. P1 is already available, and for the L1, it's a little tough. Right now, we're still doing testings just to ensure the final production quality, and I would say that's happening within Q2.
Here by Q2 is kind of the estimated time, end of Q2. So, yeah, that's good. I mean, I would prefer, and not to beat up DJI, but I would prefer that you guys take your time testing. making sure that you get, enough guys out there using it and understanding, what the workflow is. I really, again, think that this is one of those products that are likely going to have to be really understood. It brings the LiDAR capable systems into understanding, like, how does LiDAR work? What does it do? The barrier of entry always in LiDAR has been the expense and the cost, and thanks to you guys, kind of bringing this down. But we'll have to find out what it's going to be really good at as far as that goes. Would you agree? Just figuring out what's really good.
Certainly. And currently we're working hard, extremely hard, with our solution partners, just get the software implementation down. So when you guys get the product, it's ready.
Mm-hmm. Excellent. Well, Ron, thank you so much again for joining us today and being part of this presentation for our first Tech Week, basically kickoff and the first, guys. I really do appreciate it. Did you have anything else you wanted to comment on that before we just jump over and I close it out today?
No, thank you very much for having me here, and really appreciate you guys. RMUS has been really active channel partners of ours, and we look forward to work together.
All right. Thanks again, Ron, and we really do value that partnership, as well as having access to you to help out, give this information. So, so thanks again. Well, let's go ahead and close this up and say thank you to Ron one more time, allowing us to kind of pick his brain on this. Additionally, if you're watching this, don't forget this afternoon at 2 p.m. Mountain Standard Time, we have the Sarcos team coming in and talking with myself and Fraser for a moment. Fraser from up north in Canada. He's one of my technicians, as well as works with Kevin Tolderall up there. So make sure you're paying attention to the next broadcast today, 2 p.m. Mountain Standard Time. We still have a number of events coming up this week. This is going to be recorded, so you can watch this later if you have any questions on it. But also look forward to doing a little bit more intense use case and case studies with both the P1 and the L1 from RMUS. We'll try to get that information out there. We do have a level of training on our online training center that will be available for those two payloads as well. So thank you again for joining us. If I missed your question or didn't get to your question, we'll try to get those answered as soon as possible. You can go ahead and email us or let us know if you have any stock questions, cost questions, or anything like that. Go ahead and get a hold of sales@rmus.com, or if you have any questions on the training at rmus.com. So thank you, guys. Anything else, let us know, and we'll see you at the next presentation at 2 p.m.